Alright, so this video is going to be on how to fill out the unit circle. So in Math 3, I went over where the unit circle came from. So if you are interested in that, I can send you a video on like how it is constructed. But now we're just going to be memorizing the unit circle. Yes, memorizing, and we're going to be using it. So if you guys recall, there's three numbers that show up a lot, and these places down here and over here. And those three numbers that show up a lot are 1 over 2, root 2 over 2, and root 3 over 2. 1 over 2 is 0.5. Root 2 over 2 is 0.707, I think. Oh, I need to get a calculator and check that. Yes, it's 0.707, and root 3 over 2 is 0.866. So the way I think of these numbers is small, medium, large, or a little bit and a lot, okay? So here's what I mean. To write this point right here, I go to the right a lot and up a little bit. So I went to the right a lot and up a little bit. For this point right here, I went right a little bit and up a lot. So right a little bit and up a lot. So that is how I memorize the unit circle. I just think about the size of the numbers. I don't actually memorize anything. I just know that it's these three numbers. This one, I go over and up the same amount, and it's like a medium length. Okay, so left a little bit, up a lot, negative 1 over 2, root 3 over 2. Left a lot, up a little bit, so left root 3 over 2, up 1/2. And then left and up the same amount, so left root 2 over 2, up root 2 over 2. All right, I'll do quadrant 3. So left a lot, down a little bit, so negative root 3 over 2, down 1/2. Left a little bit, down a lot, so negative 1/2, down root 3 over 2. Left and down the same amount, so negative root 2 over 2, negative root 2 over 2. Right a little bit, down a lot, so right 1/2, down root 3 over 2. Right a lot, down a little bit, so right root 3 over 2, down 1/2. And then right the same amount as down, so right root 2 over 2, down root 2 over 2. Okay, the other points are all on the quadrant line. So if you guys remember, a unit circle has a radius of 1. So this is like the point 0, 0. If I went to the right, a radius of 1, then that would be the point 1, 0. If I went to the left, a radius of 1, that's negative 1, 0. If I went up, a radius of 1, that's 0, 1. If I went down, a radius of 1, that's 0, negative 1. So that's how I fill out all the x and y coordinates for my unit circle. Next, I'm going to go ahead and do my degree measures. So I've got 0 degrees here, 90 degrees, 180 degrees, 270 degrees. A full circle is 360 degrees. In between 0 and 90, I have 45. So 45 degrees, that's another 45 degrees. 90 plus 45 is 135. 180 plus 45 degrees would be 225. 270 plus 45 degrees would be 315. Okay, and then all these ones are in 30s, so 30 degrees, 30 degrees, 30 degrees. So this is 30, another 30 makes 60, then 90, then 120, 150, 210, 240, 270, 300, 330. Okay, and last we have the radian measurements, and these really are just known by knowing fractions. So this is where 0 pi is. this is where 1 pi is. Okay, so this is a whole, this is another whole pi, so 2 pi. Okay, so if I cut it in half, then this right here would be pi halves. So I have 1/2, 2 halves, which is just 1, 3 halves, and then back up here for 4 halves, which simplifies to 2. All right, right in between right here, that's a half of a half, so that's a fourth. So this is 1/4, 2/4, which is 1/2, 3/4, 4/4, 5/4, 6/4, 7/4, and then 8/4. All right, next I'm going to go ahead and do these little chunks. So if you count, there's 1, 2, 3, 4, 5, 6. So that means that these little chunks are going to be a sixth. So we have 1/6. This is 2/6, which is the same as 1/3. This is 3/6, which is the same as 1/2. This is 4/6, which is 2/3. This is 5/6, 6/6, 7/6, 8/6, which is 4/3, 9/6, which is the same as 3/2. 10/6 is 5/3. 11/6. And then the last one is 12/6. All right, so we have all of those going around. So that's how I memorize the unit circle. I go through that literally every time I write it out. Okay, a few other things you need to know. I'm going to go ahead and label up here in the first quadrant, this is our first quadrant, that all the x coordinates are positive and all the y coordinates are positive. Over here in the second quadrant, all the x coordinates are negative, all the y coordinates are positive. In the third quadrant, all the x coordinates are negative and all the y coordinates are negative. And in the fourth quadrant, all the x coordinates are positive while all the y coordinates are negative. Okay, so that's always good to know. If you guys recall from previous math classes, the x coordinate corresponds with cos of the angle that they're talking about. So cos of 3 pi halves, or cos of 180, or cos of 135, or cos of 5 pi 6. So this angle right here represents the degrees or the radians. So the x coordinate corresponds to cos, the y coordinate corresponds to sine. So x goes with cos, y goes with sine. If you're looking for tan, that is going to be sine divided by cos, okay? Which is the same as y divided by x. All right. There are 3 other trig functions that are good to know. So one of those is cosecant, which is the same as 1 over sine, or it means that you take sine and you flip it. So I'm going to say take sine and flip it. Okay. Secant is the flipped version of cosecant. So it's the flipped version of cos. And then cotangent is the flipped version of tan. Okay, so those are all good things to know. All right. Go ahead and take your unit circle and flip it over to the back. We're going to do a few examples of evaluating the unit circle. So we're going to go ahead and first we're going to find cos of 7 pi over 6. Technically, you don't need those parentheses. Sometimes you'll see it, sometimes you won't. So what you're going to do is you're going to take your unit circle, you're going to locate 7 pi sixths on the unit circle, and then the x-coordinate is the answer. So on my unit circle, I can see that 7 pi sixths is right here. My x-coordinate is negative root 3 over 2, and so I'm going to say, all right, my answer is negative root 3 over 2. Okay. Next, I'm going to have us look for cosecant of pi thirds. Cosecant of pi thirds. So that means I'm going to take my unit circle. I'm going to locate pi thirds, which is right here. Cosecant is the flipped version of sine, and sine is the y-coordinate. So the y-coordinate is root 3 over 2. So that means that my answer is not root 3 over 2, it is 2 over square root 3. Now this answer is not proper because it has a square root on the bottom, so I do need to fix that. I'm going to take this and I'm going to multiply it by root 3 over root 3. So what I'm doing right now is I'm rationalizing the denominator. So when I do that, when I multiply by root 3 over root 3, I get 2 square roots of 3 on top and 3 on bottom. So that's my evaluation. All right, let's go ahead and try tan of 5 pi thirds. Tan of 5 pi thirds. Okay, so 5 pi thirds is over here. We're going to do the y value divided by the x value. So I'm doing negative root 3 over 2 divided by 1/2. So I have negative root 3 over 2 divided by 1/2. And I'm going to go ahead, I have to simplify that. There's a bit of work to be done always with tangent. So I'm going to do keep it, change it, flip it. So I'm keeping it as negative root 3 over 2. I'm changing it to a multiplication problem, and I'm flipping the bottom fraction over. And what you'll notice is that those 2's cancel out. And we end up getting negative square root 3. Okay. All right. We're going to go ahead and do secant of 3 pi halves. So secant of 3 pi halves. So that means I'm going to look on my paper. At 3 pi halves, we are looking at the flipped version of the x-coordinate. So this is a weird one to flip because it's 0. So think about that written as a fraction. For us to take a fraction and make it equal 0, that means that you had 0 on the top of the fraction and some sort of number on the bottom of the fraction. I'm going to go ahead and call it 0 over 1. Just because that's typically how we take a whole number and write it as a fraction. So if cos is 0 over 1, then that means that secant is 1 over 0. And I cannot leave that as the answer because that is an error message in our calculator. So I'm going to say this is what I got. That means that my answer is that it is undefined. So what that means is if we were to graph secant as a function, that at 3 pi halves it would have a vertical asymptote. That's what that means. It's undefined right there. It's not a factor that cancels, so it didn't make a whole like we learned in the rational unit, but it's an x value or it's an angle measurement we're not allowed to have, so it would make a vertical asymptote. So that right there is undefined. Typically when we work with these in pre-calc and definitely in calculus, we were going to focus on the radian measurements. So I might sometimes give you degree measurements, but typically we're going to work in radians. So if you are doing these problems on a calculator active test, then I'd still be asking you to use your unit circle so you can get the exact measurements. But if you want to check and make sure that you got them correct, then you could just make sure that your calculator is in radians first. And then you can type them in. So cos of 7 pi divided by 6 is that decimal. Make it so you can see it. Negative square root 3 divided by 2 is that same decimal. So we know we got it right. If we looked at cosecant of pi thirds, I cannot type that in a calculator. So the way that I type it in, I'm going to hit alpha y equals, is 1 divided by sine of pi thirds. So there's no cosecant button, so this is where I use that I know that cosecant is the same as 1 divided by sine. So 1 divided by sine of pi thirds is that decimal. 2 divided by square root of 3, that was my original answer before I rationalized it. That's the same decimal, so that means I definitely got it right. 2 square roots of 3 divided by 3, that was my final answer after I fixed it, and that gives me the decimal, so I know that I did it correctly.